Welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use a feature or demonstrate a technique in just a few minutes. In this video, we're going to show you how to use an OH topology to avoid pole connectors in your structure grid. I have in front of you an instance of Fidelity Pointwise with a very simple structure domain. To illustrate how to use an OH topology and what your connectors look like and so on, we're going to use a very simple case of a structure grid around a sphere. So we're going to start with that domain. Let's go ahead and create that block around a sphere. So create extrude. I'm going to use a rotational extrusion, 360 degrees, 40 steps in there. I'm going to use point and direction. And very quickly, I can create a block, a structure block around a sphere. Now, what is the deal with these particular blocks? So if I go to the examine functions in here and I use, for example, cell type, and I'm going to define a cutting plane. If I get very close here, you can see that right along that line and the same line on the other side of the sphere, you basically have an area where you're going to have cells that look like this. This is a hexahedral cell with a collapsed face. A lot of solvers can actually use this and can actually deal with these type of cells, but basically there are others that cannot. Okay, so that singularity that you have along that line, that axis in there, is basically you have a pole connectors, you have a pole domain, and that singularity is causing that type of cells. Now, if your solver cannot actually use that type of cell, then this video is for you. What we're going to do is to create also a structure grid around a sphere, but we're going to avoid this type of singularity. So let's go ahead and see how we can do that. So the first thing I'm going to do is to undo that. So I'm going to go back to square one, and I want to prepare my domain to create the new topology, the OA topology that I want to use. So the first thing I'm going to do is split that domain at some particular location. Doesn't really matter where. I just want to create a section right here to kind of like eliminate that particular type of cells that we had, that singularity. So I'm going to go ahead and split that domain, select these two, and delete them. All right. So the next thing, we're going to select these and we're going to redo the extrusion just like we did before. Exact same deal, 360 degrees, 0, 0, 0, X direction, and very quickly we can create the new extrusion. So what is the difference here? If you look very closely, you can see that in that region where you had those cells with the collapsed face, that singularity, you now have kind of like a tube, like a tunnel, all right? So what we're going to do now, right, and of course you have that thing in both sides of your sphere. In our case, we're going to work with one side, the other side is going to be exactly the same. What you need to do now in order to create your full grid is to fill out that particular tunnel that you have in there with some grid, with some topology, all right? Let's go ahead and do that. The first thing that I'm going to do is to select these two sets, these two connectors right here, those two, and I'm going to split them in 4 pieces. All right, that was done. You need to make sure that all these pieces of connectors have the same dimension because you're working with a structure grid. In this case, as you can see in the status bar, they all have 11 grid points. So we're good. After that is done, I'm going to do a little trick because I need to split my little tunnel domain here in 4 pieces. So what I like to do is to come over here, make these 4 connectors a little bit thicker, and give them a different set of colors right there. There you go. And you'll see why in a minute. Next step is to, like I said, select that little tube domain and edit split. So I'm going to split that one in 4 pieces, and I'm going to use those connectors that I just colored. I'm going to use them to know exactly where I need to pick. So I'm going to select that, and that as well. So if you actually zoom out and take a look, you can see the yellow lines are actually showing you where you're going to split that domain. All right, so my domain has been split into 4. So now go ahead and select all your domains and connectors like so, and quickly create that block right there. So I now have a structure block, that one right there, in that area where I used to have the cells with the collapse phase. Now, what is the deal with this particular block? Okay, so is the problem solved? I already don't have that kind of singularity. Well, let me show you. If you go again to the examine tools and use the maximum included angle, the only drawback of this particular block that I just created is that the maximum included angle of these cells is 171 degrees. And the reason why you have that is, if you look, this particular topology has these kind of cells right here that are like skewed, and that is because of the kind of topology that you have. And in order to avoid these particular type of cells is that we're going to use an OH topology, which I'm going to show you in just a few seconds. So if your solver is okay with the 171 degrees, then you're done. You don't need to do anything else. However, if you want to improve the quality a little bit more, let me show you how you can actually do that. So what I'm going to do now is I'm going to use a script that is called the butterfly maker, and this script can be found in the Pointwise GitHub page. I'm going to show you after I finish this script how you can actually find that particular script. So just bear with me, but you do have it available to you. So what this script is going to do is going to allow me to transform that block that I created on this particular tube, that one right there, that H block, transform that into an OH topology very quickly without you having to do it by hand. So in order to make sure that this script works properly, the first thing that I like to do is select these connectors right here and make sure that they all point in the same direction and that in fact point outside from the center of your sphere, in this case, pointing out. So I'm going to go to Edit Orient, and you can see that I have 3 connectors that are pointing in, and I have only one that is pointing out. So what I'm going to do is to select the 3 connectors that are pointing in the wrong direction and basically change their eye orientation, and you can see now that everything is pointing in the correct location. So now I'm ready for the script. So let's go ahead to script, grab the butterfly maker, and you can see this little screen is going to show up. The first thing that you have to do is, of course, select the block that you want to operate on, which is that block right there. You need to specify the correct orientation for the OH topology, and then just click on the preview topology button. As you can see, the OH topology has been created. In this case, that preview showing me that my single block that I had in that tunnel section now is composed of 5 block. And this, what you see right in front of you, that is the OH topology. One thing that I'm going to do in this case is change that number from the default value of 10 to 4, and that is the number of grid points that you're going to have in these little short connectors. After that is done, I'm going to click Run and OK. You can see that now my OH topology is finished. And let me show you the nice thing about this particular topology. I'm going to select all those blocks and go again to the maximum included angle. If you remember, we had like 171 degrees, and you can see with this OH topology, I now have a maximum included angle of 123.8 degrees. So that is the reason why this is a good approach. Again, in this case, I have done this for just one side of the sphere, but the other side right here is the exact same process. The last thing that I would like to show you is where you can actually find that magical script that I use, which is this one, the butterfly maker. And I mentioned that it is located in our GitHub page. So how do you get to our GitHub page? Very simply, you go to Help. You can go to the glyph manual pages, which is going to open this website right here. This is our glyph manual pages. And then right here, you have access to our GitHub page. So click on that one you're going to have all our scripts here. In our case, we're interested in the butterfly maker. Click on that one and simply push on that green button, which is going to allow you to save a zip file with the code and some images and so on and so forth. And of course, you can read more about this particular script right here. If you like this video, be sure to click the thumbs up button and subscribe to our channel for more videos like this. If you have any questions or suggestions for future videos, drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.